In 2020, astronomers thought they'd found something incredible. The second so-called Earth Trojan asteroid was ever seen. Now a team of researchers has confirmed that it's real. Trojan asteroids are small space rocks that share their orbit with a planet, circling whatever host star that planet does in a stable orbit. While we have spotted Trojan asteroids around other planets in our solar system and others, until now, only one of these objects, called 2010 TK7, has been confirmed to orbit along the same path as Earth. In a new study, researchers confirmed that an asteroid spotted in 2020 called 2020 XL5 is the second object of its kind, called an Earth Trojan Asteroid. Think of it as an extra companion to Earth, albeit a very tiny one. The discovery of 2020 XL5 as an Earth Trojan confirms that 2010 TK7 is not a rare exception and that there are probably more. Study lead author Tony Santana-Ros, a researcher at the University of Alicante and the Institute of Cosmos Sciences, ICCUB, at the University of Barcelona, IEECUB, told Space.com. This encourages us to keep enhancing our survey strategies to find, if it exists, the first pre-mortal Earth Trojan. In December 2020, 2020 XL5 was spotted by astronomers with the Pan-STARRS 1 survey telescope in Hawaii and added to the International Astronomical Union's Minor Planet Center database. Amateur astronomer Tony Dunn went on to calculate the object's trajectory using NASA's publicly available JPL Horizon software and found that it orbits L4, the fourth Earth-Sun Lagrange point, a gravitationally balanced region around our planet and star. 2010 TK7, the first confirmed Earth Trojan asteroid, is also at L4. Preliminary results showed it was in a Trojan orbit around our Lagrangian point L4, Dunn told Space.com. Its orbit was quite uncertain at the time, so I did a more careful analysis, simulating 100 clones with similar orbits. Every clone demonstrated Trojan behavior as well. But at the time, 2020 XL5's orbit around the Sun wasn't fully understood, so it wasn't yet certain whether the object was just a nearby space rock crossing Earth's orbit or if it could be a real Earth Trojan asteroid. To confirm whether or not it is an Earth Trojan asteroid, a team led by Santana-Ros observed the object with the SOAR, Southern Astrophysical Research Telescope in Chile, along with the Lowell Discovery Telescope in Arizona, and the European Space Agency's Optical Ground Station in Tenerife in the Canary Islands. Co-author Cesar Brasiño, a researcher at the National Science Foundation's National Optical Infrared Astronomy Research Laboratory, NORALab, said in a statement that they were very challenging observations, requiring the telescope to track correctly at its lowest elevation limit, as the object was very low on the western horizon at dawn. Santana-Ros echoed how difficult it is to make these observations from Earth. It is a pain for astronomers to point to the L4 and L5 points of the Sun-Earth system while being on our planet. Any asteroid orbiting around these points will only be visible during a short time window close to twilight, at very low elevations above the horizon, Santana-Ros told Space.com. The team concluded that, as it was initially suspected, 2020 XL5 is an Earth Trojan asteroid. They also found that the object is also likely a C-type asteroid, the most common asteroid type in the solar system that is high in carbon and dark. Santana-Ros said in the same statement that source data allowed us to make a first photometric analysis of the object, revealing that 2020 XL5 is likely a C-type asteroid. The study also revealed that this object is much larger than the first Earth Trojan asteroid found. 2020 XL5 measures about 0.73 miles, 1.2 kilometers across, almost 3 times longer than 2010 TK7, which stretches just about a quarter of a mile, 0.4 kilometers wide. The team also found that 2020 XL5 won't be an Earth Trojan asteroid forever. While it will stay in its current position for about 4,000 years, it will eventually escape its gravity-bound location, according to the statement. We are fully sure that 2020 XL5 will remain liberating around L4 for at least 3,500 more years, Santana-Ros told Space.com. If we are able to discover more Earth Trojans, and if some of them can have orbits with lower inclinations, they might become cheaper to reach than our moon, and they might become ideal bases for advanced exploration of the solar system. Or they could even become a source of resources, he added. But whether or not we ever send humans to walk on them, NASA did launch the robotic Lucy asteroid mission in 2021 to study Jupiter's Trojan asteroids, and studying them can help us to better understand the universe at large. Trojan asteroids like XL5 can provide us information about the formation of its host planet and, in turn, keys to better understand the evolution of the solar system by adding constraints to its evolution models. Santana Ross told Space.com. We have studied the primordial Jupiter Trojans for several years, and we will soon have the opportunity to investigate them with in situ observations taken by NASA's space mission Lucy. NASA's Lucy asteroid mission will explore mysteries of the early solar system. Spacecraft have visited most pockets of the solar system by now, but a new region is about to come under robotic inspection: the two clumps of asteroids that flank mighty Jupiter in its orbit. Although scientists have spotted thousands of so-called Trojan asteroids in these two swarms, no mission has ever seen one up close. That will change in 2027 when a mission dubbed Lucy makes its first of 5 flybys that will turn a select few Trojans from fuzzy specks of light into unique worlds. And it isn't just about space rocks. The resulting portraits could help scientists piece together a better picture of the early days of the solar system. I've been dreaming of sending a spacecraft to the Trojan asteroids for more than a decade. Kathy Olken, the mission's deputy principal investigator and a planetary scientist at the Southwest Research Institute, SWRI, in Colorado, told Space.com. This opportunity is just outstanding. NASA's $981 million Lucy mission is a daring expedition that will make 6 carefully orchestrated flybys, 1 in the main asteroid belt, the rest among Jupiter's Trojans. The mission's agenda relies on the nimble data gathering necessitated by flyby visits and a convenient celestial alignment that offers scientists a veritable treasure trove of 8 intriguing space rocks. Hal Levison, the mission's principal investigator and another planetary scientist at SWRI, told Space.com that the team was amazingly lucky about being able to get such a rich set of targets. He added that some of these objects would be interesting objects to send spacecraft to, even if that were the only target the spacecraft was going to. That's a model the recent asteroid missions like Japan's Hayabusa 2 and NASA's OSIRIS-REx followed. Each spacecraft spent months studying its near-Earth asteroid before eventually snagging a sample to deliver to scientists. But Lucy can't stay at any one space rock without breaking the bank, since orbiting an asteroid requires much more fuel than flying past one. Instead, Lucy will become the first mission to make so many flybys in the outer solar system, and it will approach its target at a hurtling pace of 3 to 6 miles, 5 to 9 kilometers per second. That's a whopping 10,800 to 21,600 miles per hour, 18,000 to 32,400 kilometers per hour. To grasp the enormity of that challenge, Olken suggested imagining running a 10K race, but in just a second or two. I really love the challenge of it because it makes the science return so much richer, Olken said. With a flyby, every moment is precious. Similarly, although the mission stretches over 12 years, Lucy will do the bulk of its work in a total of about 24 hours, Levison said. The allure of the Trojans. From Earth, scientists can't see much detail about any given Trojan, but between the two clumps of asteroids at Jupiter, astronomers have identified more than 10,000 bodies stuck in the gravitational parking spaces ahead of and behind the gas giant planet in its orbital track around the Sun. These two clusters are called L4 and L5 swarms, a nod to the technical term for such gravitational sweet spots, the Lagrange points. And from a distance, scientists have noticed unusual diversity among the Trojan asteroids, particularly in terms of their color, which ranges from gray to quite red and is tied to expected differences in chemical makeup. Levison explains that Trojans occupy a very small region of space, and yet they're very different from one another. He adds that they really are a mystery. Levison has long suspected that better understanding the Trojans can sharpen scientists' picture of how the solar system came to be the way it is, with planets that seem impossible to form where they are found today. A model he helped develop in 2005 suggests that the 4 giant planets formed relatively close to the Sun then migrated outward, in the process scattering small pieces of debris like asteroids into the inner solar system. He said he hopes that the data Lucy gathers will give scientists a better understanding of how closely this and other theories match the real past of the solar system. When he entered the field in the 1980s, he said scientists were short on theories, but now that's changed. We've gotten to the point where I think we have more ideas floating around and don't have the data to be able to figure out which one's right, Levinson said. His hunch is that the different colors on display among the Trojans represent formation at different distances from the Sun, with the migrating planets kicking them into the gravitationally stable regions ahead of and behind Jupiter. Comparison among the Trojans and among asteroids, in general, is at the heart of Lucy's science. These guys have been sitting in the same place, and so they've had the same evolutionary pathway since they got trapped in their swarm, Levinson said. So the differences we see really are going to be fundamental differences on the bodies. To that end, the flybys are coordinated so that the scientists can easily compare the details of observations gathered at different asteroids. Among others, the observations include color photographs of the Trojan's surface, infrared spectrometry to identify different compounds on their surfaces, and analysis of Lucy's communication signal from Earth that will tell scientists how dense each asteroid is. Now that you've watched the video, let us know what you think by leaving a comment in the section below. Thanks!